Hi students and friends, welcome to the channel Learn and Teach by Ayaz. So I was solving the CAI 5070 past paper specimen paper 2. So I will continue with that specimen paper. The specimen paper is paper 2 and for this one we have question number 6. Let's start. A mixture of ethanoic acid, ethene, and oxygen is passed over a catalyst at 200 degrees centigrade to manufacture ethynyl ethanoate. This is ethynyl ethanoate, CH3COO CH double bond CH2. And this is the reaction. The reaction is exothermic. Part A. Draw a reaction pathway diagram for this reaction on figure 6.1. This is figure 6.1. On your diagram, label the axis, meaning that you have to label that both x and y axis, the reactants and the products, the enthalpy change of the reaction delta H, the activation energy EA. This is an exothermic reaction, so the product will be at the lower energy state than the reactant. So we'll get, first of all, we will label the x-axis. On x-axis, you can even write progress of reaction. Or you can write extent of reaction. You can even write reaction coordinate. On a y-axis, we know that in energy or enthalpy. That's it. Both x and y-axis are labeled. Now, I'm drawing the reaction pathway. This is an exothermic reaction, so the reactants are at the higher energy state than product. So this is the reactant, and this is the product. You will get energy hump like this. So on the reactant side, you will write the reactants, formula of all the reactants. On the product side, you will write the formula of all the products produced. Now, enthalpy change of the reaction. It's the difference between product and reactant, so you will have enthalpy change here. This is the enthalpy change, delta H, and it's negative. What about activation energy? Activation energy start from this line, go in the highest level of this hump, energy hump. This is energy hump, and it's represented by EA. Sign will be plus. Remember, in activation energy is always positive, either is exothermic reaction or endothermic reaction. You will get ECF if you draw the diagram for endothermic reaction. B. Explain why the enthalpy change of the reaction is exothermic. Use ideas about bond breaking and bond making. First of all, you write bond breaking. What's bond breaking? Bond making. Bond breaking is endothermic. And bond making is exothermic. A more energy released than absorbed. More energy released than absorbed. Now you are allowed to write heat instead of energy. You can use heat instead of energy. More heat. You can write heat. More heat released and absorbed. Question number 7. Peroxo disulfate ions S2O8 2 minus react with iodide ions in aqueous solution. This is a reaction. Iodide ions are oxidized in this reaction. You can see here it's oxidized because oxidation number decreases. Here it's -1. and on this side it is 0. So oxidation number increased or increases. State how the equation shows this. So looking at the equation, you can easily write iodide ions lose electron. Iodide, don't write iodine. Iodide ions lose electrons. Minus charge means it has one electron. So if it's moving to the 0 side, it means it has lost that electron. B. Table 7.1 shows how the relative rate of this reaction changes when different concentrations of peroxosulfate, disulfate ions, and iodide ions are used. This table 7.1. These are the experiment. Experiment 1, 2, 3, 4, 5. You see the concentration of S2O82 minus in mole per dm cube. It's different. Similarly, the concentration of iodide I minus ion is also different, and related rate is also different. So what they are asking, using the information in table 7.1, describe how increasing the concentration of each of these ions affects the relative rate of reaction. First of all, see the peroxodisulfate ion. If you look at this, compare it, 0.008, 1.7 is the rate. For 0.016, doubling the concentration, what will be the rate? 3.3, 0.032, again, double the rate. So it's very easy. You can write for this one, increase rate or doubling concentration doubles the rate. Doubling concentration doubles the rate. What about iodide ion? Well, let's talk about iodide ion. Look at the concentration of iodide. 0.02 is 1.7. 0.02 again, it's increasing 3.3. Now if you increase 0.04, what's happening? Rate doubles. 1.7 to 3.4 doubles. 1.7 multiplied by 2, you will get 3. You will get you will get what? 3.4. Similarly, if you have 0.08 concentration of iodide ion, again the rate doubles. So 3.4 multiplied by 2 gives 6.8, and here it's 6.9. So the same, doubling concentration doubles the rate. Doubling concentration doubles the rate. Iron 3 ions Fe3 plus catalyze this reaction. Explain how catalyst increase the rate of a reaction. How catalyst increase the rate of the reaction. It decreases the activation energy, so you'll write activation energy decreases. Activation energy decreases. So more particles have energy above that of the activation energy. More particles have energy above that of the activation energy. Above that of activation energy. Number 8. Copper reacts with concentrated nitric acid to form copper 2 nitrate. This is a reaction. State the meaning of aqueous. It's very easy. Aqueous means solution in water. AQ is aqueous. You can either write aqueous or solution in water. And some salt soluble in water. We'll write solution in water. Part B, an excess of copper is added to 25 centimeter cube of 6 mole per dm cube HNO3. HNO3 is nitric acid. Using this information together with the equation to calculate the volume of NO2 formed. The gas volume is measured at room temperature and pressure. Show your working and state the units. You have to show the working. So what we have? We have the volume and concentration of nitric acid. This is nitric acid, and we need the volume of nitrogen dioxide, NO2. So we need the moles of NO2. So I'll write here HNO3, 4 moles produces 2 moles. So first of all, we'll calculate the moles of acid, that is nitric acid. So according to the information, 1000 centimeter cube contains 16 moles. Therefore, 25 centimeter cube contains X. Do the cross, you will get what? X is equal to 16 multiplied by 25 divided by 1000. Okay. So you will get 0.4 moles of acid. So here you will have 0.4 moles of acid produces X moles. X is equal to 2 multiplied by 0.4 divided by 4, 1, 1, you will get 0.2 moles. Now you have the moles of NO2, you can easily calculate the volume. Simply multiply it to 24 by 24 dm cube. 0.2 multiplied by 24. So what you will get? You will get 4.8 dm cube. So your answer will be 4.8 dm cube. Or if you want to express it in centimeter cube, it will be 4800 centimeter cube. When heated, CuNO3 decomposes to form CuNO2 and O2. Construct the symbol equation for this reaction. You have to write the balance equation. We know the formula of the reactant CuNO3. It's a decomposition reaction and produces CuO plus NO2 plus O2. So we have N is 2 moles on reactant side, and on the product side it's 1. Oxygen is 6, and on the product side it's 5. So if I will write 2 before Cu, it will become 2CuO, then 2 to the 4, 4 NO2. What about oxygen? 2 3 is 6, 6 to the 12, 4 to 8, 9, 10, 11, 12. Now it's balanced. The equation is balanced. D, to a small sample of CuNO3 whole twice aqueous, a student adds aqueous ammonia drop by drop until it is in excess. Describe what is observed. Blue precipitate or blue solid? Blue precipitate or blue solid. It's soluble in excess, so you'll get in excess becomes a dark blue solution. In excess, dark blue solution obtained. Part 2. The student repeats the experiment but adds aqueous sodium hydroxide instead of aqueous ammonia. Describe what is observed. Remember, again, you will get blue PBT of copper 2 plus ion, but this time it's insoluble. So you'll write what? You write, first of all, you'll write blue precipitate. Precipitate. Then you write which does not dissolve, insoluble in excess. Insoluble in excess of NaOH. 9. Iodine reacts with chlorine to form iodine 1 chloride ICl. Iodine 1 chloride reacts in a similar way to bromine. Iodine 1 chloride reacts with ethene in an addition reaction. Draw the display formula of the products of this reaction. Ethene. Recall the formula of ethene. The formula of ethene. You see the carbon-carbon double bond. So how it reacts with bromine? It reacts bromine in this way. It's an example of addition reaction. What you have to do? You have to add only bromine to both carbon atoms. Now they are mentioning here iodine, 1 chloride reacts in a similar way to bromine. So it will be very easy to predict the product. Draw such a saturated form of ethene, which is ethane. And here you have ICl, so you write I and Cl. Very easy. B, iodine 1 chloride reacts in a similar way to chlorine. Now, iodine 1 chloride reacts with ethane in a photochemical reaction in the presence of ultraviolet light. What will happen if chlorines reacted with ethane in a photochemical reaction? Is the formula of ethane C2H6. Whenever it reacts, it will produce a substitution product C2H5Cl plus HCl. So if ICl is reacting in a same way, so you can easily predict the product. First of all, state the type of reaction that takes place. The substitution reaction. Number 2, suggest a symbol equation for the reaction between iodine 1 chloride and ethane. Symbol equation. It's very easy. You can write either this C2H6 plus ICl. You can write any one of these. You can easily predict the product. Either C2H5 Cl plus HI or C2H5I plus HCl. Both are correct. 9C. The dot and cross diagram for a molecule of iodine 1 chloride is similar to that for a molecule of chlorine. Draw the dot and cross diagram for a molecule of iodine 1 chloride. Show outer electrons only. Recall the diagram of chlorine molecule. It will be like this. Both contain 7 electrons in their valence shell, and both need 1 electrons to complete their valence shell. 1, right? 2, 3, 4, 5, 6, 7. For this one, 1, 2, 3, 4, 5, 6, 7. Now here what you are having? You are having iodine chloride. Iodine chloride. We show the key. For iodine, I'm using dot. Chlorine, I'm using cross. Chlorine. 1, 2, 3, 4, 5, 6, 7. Iodine. 1, 2, 3, 4, 5, 6, 7. It's easy. D. Iodine 1 chloride reacts with chlorine to form iodine 3 chloride. The reaction is investigated at 200 degrees centigrade in a closed system. The reversal reaction reaches an equilibrium. This is the reaction. Describe 2 features of a reversible reaction equilibrium in a closed system. In your answer, refer to the rate of reaction and to the concentration of the reactants and product. It's very easy. In any reversible reaction reaching to a dynamic equilibrium state in a closed system will always have rate of forward reaction equal to rate of backward reaction. So you can write rate of forward reaction is the same as the rate of backward reaction. As the rate of backward reaction. And the concentration of reactants and products do not change or remain constant. The concentrations of reactants and products do not change. Can even write remain same. Number 2, the pressure of the equilibrium mixture is increased. The temperature is kept at 200 degrees centigrade. ICLG. Gas is a dark brown gas. ICl3 gas is a yellow gas. Predict and explain what will happen to the color of the equilibrium mixture. First of all, you have to predict. So look at the number of moles. So if you're increasing the pressure, the equilibrium will shift towards the side in which there will be less number of moles of gas. So on the reactant side, there are 2 moles. 2 moles on the reactant side and 1 mole on the product side. So it will move to this direction. Equilibrium shift to right side, the product side. The product side is ICl3. Solution of color becomes more yellow. Color becomes more yellow. Or you can write the color becomes less brown, or color becomes less brown. You can even write goes yellow, it's yellow. So what will be the explanation? Fewer moles on the right hand side. Fewer moles on right hand side. On right hand side. So the position, position of equilibrium move to the right. Move to the right. Question number 10. Air contains a mixture of gases including the noble gases, neon, argon, krypton, and xenon. These noble gases are monatomic elements. State what is meant by monatomic. Exist as atoms. Atoms unbonded. Atoms unbonded or exist as atoms. B. State why noble gases are unreactive. You can write complete valence shell, stable outer octet. Complete valence shell or has a stable electronic arrangement or has a stable electronic configuration. C. State why fractional distillation can be used to separate a liquid mixture of neon, argon, krypton, xenon. It's very easy. Have different boiling points. They have different boiling point because the theory is based on the different the boiling point of liquids. D. State which noble gas, neon, argon, krypton, and xenon has a faster rate of diffusion at 200 degrees centigrade. Look at the mass. Neon is the only choice because it has low mass. So you write in the explanation, smallest relative mass has the smallest relative atomic mass. The air also contains oxides of nitrogen that are pollutants. State one adverse effects of oxides of nitrogen in the air. Photochemical smog or acid rain? Acid rain or photochemical smog. You're even allowed to write ozone depletion. Number two, with the aid of symbol or word equation, explain how oxides of nitrogen such as NO are formed within a car engine. The reaction between nitrogen and oxygen N2 plus O2, what you will get? You will get 2NO. You can write the word equation for this and the condition spark or high temperature. Spark or high temperature. Number 11. Table 11.1 shows some information about the homologous series of unbranched carboxylic acid. This is unbranched carboxylic acids. One of the characteristics of homologous series is that it has a general formula. To deduce the general formula for the homologous series of unbound carboxylic acid, you have to recall this: CnH2n plus 1 COOH. Part 2. Describe two other characteristics of homologous series. You can write any of these series like they have same functional group, or they have what? Same chemical properties, same method of preparation, idea that each member differs by CH2 group, member differs by CH2 group. You can even talk about physical trend in physical properties. Part B. An aqueous solution of propanoic acid is a weak acid. Define the term acid. Easy. Release hydrogen ion. Butanoic acid reacts with ethanol to make an ester. State the name of the ester made and draw the discrete formula of the ester linkage. It's very easy. The alkyl group comes from the alcohol. Alkyl alkanoate. You'll get alkyl alkanoate is coming from alcohol, and alkanoate is coming from carboxylic acid. So you'll get what? Ethyl butanoate. The split formula will be like this: 4 carbon for butanoic, 1, 2, 3, 4, 2 for ethyl, showing each hydrogen atoms. Ethanoic acid is a liquid at room temperature. Describe the changes in arrangement and movement of molecule of ethanoic acid when it's heated from room temperature to 120 degrees centigrade. So 3 marks question. The molecules have more kinetic energy as temperature increases. Molecules have more kinetic energy. First of all, you write this. Second thing, the further apart at temperature increases. Molecules further apart as temperature increases. Last point, they are arranged more randomly, or you can write more irregularly. Molecules arrange more irregularly as temperature increases. Thanks for watching. Please like, share and subscribe my channel. For more videos, subscribe to my channel.